Alright, let's look at the complex conjugates. Right? Let's say a complex number z is equal to a plus bi. Right? Complex conjugate, so they use we use z bar is equal to real part stays the same, but the imaginary part gets negated, so negative bi. Right? Then geometrically, what happens is, let's say you have a z, right here, right, in complex plane, and z bar is going to be simply the reflection about the x-axis. Maybe I should write that down. So this is the reflection about the x-axis. So this guy is going to get reflected over to the other side of x-axis. So here we have negative b. Real part stays the same, so it's going to be right here. Right, so this is going to be z bar, right, conjugate of z, right. Then so in a rectangular coordinate system, this is just a reflection about the x-axis. And another way to look at it, it would be if you looking at the polar coordinates, for example. So if you have right, so this angle is going to be theta, right, and r stays the same, but the complex conjugate is going to be the negation of the angle theta. So it actually goes this way, negative theta, right? So if you're looking at the polar coordinate, the z bar is going to be, right, so magnitude doesn't change, so r stays the same, but the angle gets negated, so it's negative I theta. Right? We can actually check with the if you write it in terms of sine and cosine, so z can be written as r times and cosine of theta plus I sine of theta, right, using Euler's formula. So you have r cosine of theta plus I times r sine of theta, right? Then another way to look at it would be if you negate the, take the conjugate, so taking a conjugate of everyone, right? So just negating the imaginary part, so r cosine of theta stays the same, but it's a negative I r sine theta, right? Then r cosine theta, since cosine is an even function, we can plug in negative theta, but it doesn't really change the value, right? And the negative sine of theta is equivalent to sine of negative theta, since sine is an odd function. So we can write it as a plus I r sine of negative theta, right? So you can see that using the Euler's formula, we can rewrite this guy as pull out r, right? Cosine of negative theta plus sine I sine of negative theta is e to the negative I theta, right? So this checks out right here, right? But this is a complex conjugate, just means that the negating the imaginary part, and geometrically it's just a reflection about the x-axis, and in polar coordinates it's just negating the angle theta. All right, that's it. I hope that this was clear.